Welcome to The Machine, a podcast from Waterford Institute of Technology. My name is Rob O'Connor. I'm a lecturer in the Department of Computing and Mathematics. Today, we are going to discuss how the internet works, and I'm joined by two lecturers in the department who specialise in networking. We have Amanda Freeman-Gater.
Hiya, Rob.
And we also have Richard Frisby.
Hi, Rob.
Now, I said we were going to talk about the internet, but we're actually not. We're going to talk about Brexit, Northern Ireland, and all of those things. Let's see, what other complicated topics could we discuss?
Lovely.
Boris Johnson.
Yeah, we'll talk about that. No, but let's talk about the internet. It's much less complicated. Okay, so I'm just going to read you a definition. Now, I just got this off Technopedia, okay? The internet is a globally connected network system that uses TCP/IP to transmit data via various types of media. The internet is a network of global exchanges, including private, public, business, academic and government networks, connected by guided, wireless and fibre optic technologies. The term internet and World Wide Web are often used interchangeably, but they are not exactly the same thing. The internet refers to the global communication system, including hardware and infrastructure, while the web is one of the services communicated over the internet. Now, that's a lovely, dry piece of prose. But I want to present you with a scenario, and we might kind of explore this scenario over the course of this podcast. Let's say I click on a link in a browser. Mm-hmm. What happens? Let's say I click on wit.ie, okay, and I want to see that web page. What happens?
Okay.
What happens next? So go for it, Richard.
Right, so at a very high level, when you click on wit.ie in a browser, what will happen is that name, which is called a uniform resource locator, that URL has to be converted into something that's readable by machines. Okay, so really what happens then is the first thing that happens is it will try and figure out, well, have I got a number for that? So it's a bit like when you look at your contacts and lists on your phone. There's no way that you remember all the mobile phones of your friends. So effectively, you'll look up mom or dad. Well, you might know those, but maybe what's Jimmy's number? So I don't remember Jimmy's number, so I'll just look up his name and I'll hit dial. So the same with www.wit.ie. You have to go to a phone book, and that phone book is called the DNS. So it looks up what's the number.
And what does DNS stand for?
Domain Name System.
Okay.
So it goes off, and I'm not. Some people will call it domain name service, but it'll go off and look up what's the number that WIT is at, that www.wit is at, and then through a series of connections it goes and finds out where WIT is at, and then says, "Here, give me your web page." And so that's at a very, very high level. When you click on that link, the first thing that happens is the lookup of the actual address, the IP address of the server that the college's web page is hosted on.
So IP is Internet Protocol, and protocol is like a standard or a set of rules, and an agreed set of rules upon which things work. So maybe, Amanda, you might be able to tell us, what is an IP address?
Well, I suppose it's a way that they had to come up with that we could all globally communicate together. If you look back on early networks, they were islands on their own, and they wanted to try and come up with some kind of a way that we could interconnect everything. And I think that's where the whole idea of, an IP addressing system that we could all use. That's where we came up with this whole idea. Usually it's a 32-bit number that we represent in binary, which is back to what Richard said, numbers that the machine understands.
But somebody might see, if you've tried out any of this kind of stuff, you might see them, I have an IP address of 192.168. Yeah. Now, actually, you don't, because that's a facade and something else, but we won't get into that for now. But IP addresses are, generally speaking, unique across the world.
Yes.
So it's like your phone number,
yeah,
essentially.
Yeah.
Except it's a big, long string of things.
It is.
Okay, so the request goes up to a server for the WIT address, for the WIT page, and then it comes back down. That all happens through a nebulous thing called the cloud. Now, okay, I'm going to look at you again, Amanda. Could you maybe tell us what the cloud is?
Well, as Richard always says, the cloud is different things. It's many things. It's hard to define what the cloud is. I suppose if we're talking in terms of what's happening here, we're clicking on a web page, it's going across the network infrastructure. And it's going through a series of routers, and it's going across fibre optic cables. And it's not obviously up in a cloud. There's a lot of hardware involved in this information travelling across.
Yeah, I love it when people say, "Oh, the cloud." Like the cloud doesn't exist. Yeah. It's just an abstraction, really, isn't it?
Yeah.
Okay, so what's a packet then? Could you make? We haven't introduced that term yet, but we might introduce it now. Richard, what's a packet?
Okay, so we now have figured out that every machine on the internet has an IP address. To be probably more correct, it's every network card that a machine has. So your laptop or your laptop has a Wi-Fi network card, and it also has a wired card as well. So they will have unique IP addresses as well. So those addresses identify the end points. And then what we need to do is we figured out what that address is. Now we need to actually retrieve the information back. So going back, what was your question again, Rob?
What's a packet?
A packet then is the message is too big. A message that's sent across the internet is too big to be transported all in one go. So what happens is we break that message up into smaller messages. So a packet really is just a container, like for a small part of an overall message. So it kind of goes back the early days of networking. We had these things called, like you'll mention it later on, a circuit switch network, and then we had packet switching. The circuit switch network, you can compare it with the old telephone system.
Yeah, sure, we might as well do it now. So
Yeah.
maybe make that distinction between circuit switch network and packet switch network.
So a circuit switch, I often would use the story about like the Waltons, and I would say when John Boy used to ring down to the doctor, and he was up in Walton Mountain and they needed the doctor, he picked up the phone and there was a connection made to the grocery store, and whoever the grocer was in the grocery store connected in the telephone line from John Boy's house into the doctor. So you see it on the old black and white films whereby you had a circuit being established from John Boy's phone to the doctor's house. So
you're showing your age there now by invoking the Waltons, Richard.
Yeah. So yeah,
the old switching, isn't it?
The old switching. So that was an end-to-end connection.
Yeah.
And the idea was for the duration of that call, that circuit existed. And equally, the telephone then could not be used for other calls.
Exactly. And now what happens on the internet is we still kind of have those circuits, but the messages are broken up into packets. Now, the packets don't have to go on the same pathway. So they don't have to go from point A to point B, always along the same wire. So packets can go many different ways and ultimately get to the destination. So a packet, as I said, is a smaller part of an overall message. I often, again, another analogy that I use is maybe if you're going to Dublin on the motorway. So most of your packets, you can see them as being cars. Let's say the three of us are going up to Dublin up to a match. Three of us hop into our cars and we're driving up to Dublin. But maybe we come across an accident on the motorway and you have to turn off at one of the junctions. So I've left 10 minutes before you, so I can continue on the motorway the whole way up, but you got delayed at that traffic accident and you ended up going off at Paulstown, coming back on later on up at Carlow somewhere. Yeah. So you've taken a different pathway. You're one of the packets. You've taken a different pathway, but we still all get to the match up in Dublin. So that's what kind of messages on the internet, they're broken up into smaller packets, and these packets can take different ways, but they ultimately get to the same destination, hopefully.
And I suppose if you think about it, it's more efficient to have it that way, because in the old way with the circuit switch, there was only, it was like if we were one line between us and if we weren't sending stuff, there was an idle time on that line. Whereas now with the smaller packets, we can send them. It doesn't matter which way they travel,
I remember in the olden days, back years ago when we were small, and if you didn't put the phone back on the hook properly, it'd be nobody else could ring because it was like the phone was still in use. And
even
again,
with the dial-up, we all had that back in the day. Our parents killing us because nobody could ring the house because we were ding, 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 and
but that's another day's work of the internet policy in Ireland. So, I might I like your analogy about the kind of the cars and stuff like that, but I might use a kind of another analogy, and I might throw this at you, and you might tell me whether I'm right or wrong or somewhere in between. So let's say I want to build my own bike. and I'm buying parts for a bike from a shop in Dublin, and maybe they send me down the frame, and then the next day they send me down the wheels and saddles and things like that. And it comes down in different parts, and the courier for the first part comes down the motorway, but the second courier might come down via Wexford from Dublin to Waterford, and then the third courier might come somewhere else, and then I get the bike here in Waterford at home when it's delivered to me, and then I'm able to put that together to assemble the bike the way that I wanted it to be. Is that a fair representation of when I ask for wit.ie on the browser, the information for that web page is sent to me in different packets through a variety of different ways and means across the internet, the cloud. It comes on my browser, and it reassembles the information in the packets in the correct order so that I see wit.ie webpage.
Yeah, which is back to what you said earlier about protocols and what are protocols. So I suppose what we didn't add there, that in a packet that's been sent, it will have a source and destination address, but will also have a protocol number in there as well.
Okay, so maybe could you give us another example of these
protocols?
So
for this packet going across the web, that's going to be using HTTP. So the packet will have in that's going to what we call port 80, which is HTTP, which is how the machine who's receiving it knows actually this is a web request.
Okay, so the port numbers indicate what kind of traffic it's for. So for example, port 80 is web traffic.
Yes.
Whereas if you had port 25 is email traffic or something, was it?
Yeah.
Or old email traffic. I can't remember all the port numbers.
And back to your point about how do all these packets get put back together again? Well, that's down to protocols, which is what we call the TCP protocol or UDP, transmission to control protocol. And what that does is it sequences those packets and it makes sure that when those packets arrive, that they're put back into their proper order.
Okay, so the packets mightn't actually arrive in sequential order. I could get the last bit first, something from the middle, then something from the start, and blah blah. But because they're labelled correctly, my computer is able to reassemble it, and again I see this. Now I suppose I probably should state this all happens incredibly quickly.
Yes.
So I was using the bike analogy. That takes ages. But this all happens in a couple of seconds when I'm asking for a web request or anything else. Okay, what happens if packets don't arrive at their destinations?
What using this protocol that we call in TCP, it will look for an acknowledgement. So it'll look to see, if we sent a packet, it's going to wait for an acknowledgement. If it doesn't get an acknowledgement, well, then it'll be resent again.
So the acknowledgement is I say, hey, I got that, Amanda.
Yeah, or I didn't.
Okay, so then you can send it again.
If I don't get an acknowledgement, I know that they didn't get it.
And you can just send a copy of that again.
Yeah, retransmit.
Okay, but not all protocols do that, isn't that correct?
No,
so Richard, there's another protocol. So TCP
Correct.
does that, but there's other protocols that don't do it.
Another protocol that we'll assume that the actual message is going to get there. So UDP is the user datagram protocol, which operates at the same kind of level as TCP, but that doesn't actually have this acknowledgement set up. So if it doesn't have the acknowledgement set up, it's actually faster. So an awful lot of gaming applications would use UDP as opposed to TCP. And the same with voice over IP, voice traffic on the internet. They would use UDP as a transport layer. There's another transport layer called QUIC that Google have kind of developed, and it's in the Chrome browser as well. So there's a number of different protocols there. So these are just different rules for processing the packets and how they're handled. Yeah.
So depending on the application, you might use a different protocol. So say, for example, if a web page is missing information, let's get it again. But if you have a real-time situation, that extra time of the acknowledgement could be detrimental to performance. So let's say it was a voice call on a Skype type situation. Mm-hmm. Sure, look, if something gets lost along the way, it's better to have lost it and be able to carry on than always ask for the acknowledgement and resend it. Is that correct?
We'd barely notice it maybe if a packet was gone in a voice call. It might just be like a little bit of an interrupt or something, but we barely pick it up. Same with YouTube and things like that. We wouldn't maybe so much notice it. Okay, whereas if an email is being sent, we have to be sure that email was sent exactly and it was received exactly as it was sent. Okay,
I love the way you invoked YouTube there. So YouTube might be something where people have experienced those issues. So buffering, what's that? What's buffering?
Well, buffering is like
My kids say that, by the way.
Sure.
I don't even think they know what it is.
Oh, it's
So,
buffering.
Oh, it's buffering, Dad. Yeah.
It's like there's actually an algorithm behind it which I think is very aptly named, called the leaky bucket algorithm. Yeah, and there's a leaky bucket.
Brilliant.
So it's effectively, if you want a constant feed of drops of water, the bucket might be half full or it might be completely full. But if you've got a hole in the bucket, it's going to be just leaking out pretty much at a constant rate. So a bit like like YouTube, if you're streaming a video, what will happen is that video is going to arrive, depending on the courier, the speed that the courier came down from Wexford or he came down the motorway, they're going to arrive at different times, but they're all going to get to the same destination. And you want to actually put them in sequence, back in order, and you want to actually play the video at a kind of a constant rate without it being jerky, without it pausing and so on. So buffering is what happens when you fill up that bucket, and then the drops that are coming out of the bucket, they're coming out at a constant rate. It's being played back in your browser the way it should be. Okay, so
Even though you might actually have all the information.
yeah, so
And you'd often see it, if you ever look on a YouTube video and you'll see the line filling up, or if you're like me and you live in the country where you've got crap broadband, you might get to the point where you have played back more than information you have.
exactly.
And that's when you get what the kids call buffering.
Yeah, exactly. So it's waiting to fill the bucket up again. So the bucket has been empty, the buffer is empty. So you're waiting now for more data to come in to be played back. One other thing I'll just mention, as well as the checking that everything is there, one of the other features of the TCP setup would actually be for handling duplicates, because sometimes stuff you think has gone missing actually isn't gone missing. It's like that courier when he came down, and he could have stopped in Wexford for a cup of tea. Okay. And then you're waiting on your wheel for your bike. So you bring him up and say, "Here, lads, like I can't cycle. It's a bicycle I ordered, not a unicycle." Like so we'll stick another wheel okay, it's not applicable.
No, I know, but in an analogy,
So you end up with 2 wheels.
Yes.
Yeah, sorry, 3 wheels in total. So effectively, you're going to return one of them. So the other kind of impact of TCP is also removing duplicates. So that's a big deal. Like if you were transferring money from one bank account to another, so an extra 0 is received. So you don't want to be transferring 1 million instead of 100,000,
or
whatever.
making 2 transfers to you. I sent you a transfer,
Yes,
that got
twice.
lost, or one was slow.
Yeah.
I send the other, and then it sends a copy. And
So
Richard is happy, but I'm not.
Yeah.
Yeah. Okay. So that actually is a very good analogy. So I might go back to maybe something that I talked about at the start, which is about the internet. It's a network of global exchange. The internet. Am I correct in saying that the internet doesn't exist? Am I correct in saying the internet is actually a kind of a contraction of interconnected networks? Is it?
I think internet working maybe the first kind of a term with it. A network of networks, internet working them.
Yeah.
Right. And where did it come from?
Okay, so yeah, like everybody has different viewpoints on it. Everybody has different, I suppose, as Amanda was saying, different interpretations of what the cloud is. People think the internet is different things. And so really it started back in the 50s and 60s when they were looking at trying to connect computers together. So in the academic institutions, in the universities, in the States, and they wanted to have a system that was fault tolerant, was able to put up with one of the links going down, and they wanted to be able to share information in a way that it wasn't going to be lost if one of the connections went missing. So I think that was its origins, and I think ARPANET was one of the first networks that.
And was that funded by the American Department
yeah.
of Defense? Yeah.
So
that was kind of, I think, I was looking at something recently where they were saying that when the Russians launched Sputnik, the Americans were kind of getting worried that they were losing the technology war, and they started to put some more money into looking at these kind of things.
And that wasn't just, it was seen as a tool for connecting, they obviously didn't dream of the World Wide Web, and we talked about websites, but it was a way of connecting information from a computer in MIT to a computer in Caltech,
Totally.
perhaps.
Exactly.
That's what it
Totally.
was seen. It
Yeah.
wasn't seen as a kind of a communications device for
No.
Joe and Josephine Soap
No.
out in the world. Okay.
No, and so in the 50s and 60s, that's kind of the origins of the establishing this network. And then in the 70s, a lot of the rules, the protocol started kind of taking shape. Because I think the first email was sent in 1971. So that's when the @ symbol was first used in emails being sent. And that was actually before IP. So IP addressing, that only came around about in the late 70s. So around 1978, you had your first IP address. So it was a gradual process that has happened over the last number of decades. So other IP is great, but it's around since the 70s. It kind of showed its age then in around the mid-90s, when then we started running out of addresses.
Yeah.
So what do you mean about running out of addresses? Why would that be?
So like Amanda said earlier, an IP version 4 address is a 32-bit address, which makes for about 4 billion addresses. But there's a lot more than 4 billion devices speaking on the internet as we know it today. So it actually wasn't the address itself that was in short supply in the mid-90s. It was more the number of networks. So we started running out of network addresses. And another analogy would be, if you've got a postal address, so Rob at number 10 Main Street in Watford, yeah. So the postman is he delivers the letter to Rob in number 10 Main Street, but number 10 Main Street is the network address. The postman doesn't care if it's for Rob or for it's John or for Jane or whoever. He just wants to drop the letter in the letterbox of number 10 Main Street. So these network addresses is what we started running out of. And in the kind of mid-90s, there was a new protocol developed called IP version 6, which was addressing the shortcomings of IP version 4. But we're still using IP version 4.
Yeah.
And it's since 1978, it's stood the test of time. But yeah.
So so IPv4 is a 32-bit addressing structure. So that means there's 32 ones and zeros in sequence. IPv6 is 128 sequence, but that doesn't mean 4 times bigger. It's actually a lot more than that. So, I mean, I can't remember.
Trillions. I have a slide that I do with the schools. It's, they reckon someone in our age group, 8% of those addresses might be used in our lifetime. There's so many of them.
Yeah. So
and with this whole area of Internet of Things and stuff like that as well, we're going to need.
But they're famous last words, though, because I'm sure they said back in the 70s.
Oh, sure.
32 bits, 4 billion, whatever addresses. Sure, we'll never need that many. How wrong.
They hadn't even envisioned, the desktop then.
Yeah.
But yeah, I think we're probably going to be okay with IP version 6 though, because I think
there's a lot
of the mathematicians would get a lot of kicks out of trying to compare the number of IP version 6 addresses to the grains of sand in the world and stuff like that. So yeah, I think we're going to be okay.
Here's one for you now. Again, this could be total nonsense, but I remember reading before, whether it was an urban legend or whatever, that one of the reasons why the US Department of Defense threw so much research money at this kind of computer networking project was that they were looking for a networking system that was robust enough to withstand a nuclear attack, so that if a city was wiped out, that you'd still maybe be able to communicate between the east and west coast. Is that true?
That's
and makes sense as well, I suppose, which is where the packet switch networks are great. Like with the circuit switch networks, it could just bomb and wipe out so much, whereas now the packets can take many routes.
So again, if that line is closed, it can go another route to get from point A to point B.
It's like using your Google Maps or your AA route planner. So if you discover that there's an accident or there's roadworks, your Joan or Jane or whatever will recalculate your route, and you'll take a different pathway to get to the destination. So you're 100% correct. Yeah,
so it is true.
It is true.
I remember reading years and years and years ago. I think this is maybe 10, 15 years ago. I read a book, and I've just looked it up there now while we've been chatting. Where Wizards Stay Up Late: The Origins of the Internet. And I remember I actually got it from the library in WAT at the time, and it was kind of all about those early engineers and computer scientists who were working on this kind of computer networks problem. And one of the things that kind of struck I can't remember all the detail in the book, but I do remember that it wasn't a problem that just the Americans were working on. That there was researchers in Europe and in Australia and Japan and in the UK who were also working on similar issues at the same time. And if I remember correctly, the whole idea of packets was actually, I think UK researchers and US researchers came up with a similar thing independently of another.
Yeah.
So things are just kind of moving in that direction, were they?
Yeah, they were. So, yeah, like I suppose there's a lot of debate over who came up with the ideas. Like you're saying there, European researchers and network people came up with the same ideas pretty much as Americans, as Asians and so on. So it wasn't until, I suppose, the 70s and 80s when they started linking the continents together and so on that we had to establish rules, these protocols and agreements to allow things to talk to each other and have a standardized setup. And that's where I suppose one of the bodies on the internet is called the IETF, the Internet Engineering Task Force. And they come up with rules there that all the different countries would agree to implement in terms of the protocol. So if you were actually developing a new product, a new software product, it would adhere to some of these rules to allow it to be interoperable. One, just when you're talking about the evolution of the network and the internet as well, one important development in the 90s was the setup of the Internet Exchange up in Dublin. So we really the HEAnet, which is the Higher Education Authority that links all of the universities and institutes of technologies together, that they established kind of a central hub up in Dublin. And it meant that if at the time the ISP would have been Ireland Online. Okay,
go back into the history.
When they had about 3 or 4 ISP service providers, and instead of the traffic leaving Ireland, and if I wanted to send a message to Joe up in Donegal, but he had a different provider, it actually could go through an exchange. So that exchange was the iNet hub up in Dublin, and over the years, then a lot of the big tech companies, you didn't have to be just a service provider, but you were actually providing kind of content like Amazon and Netflix. They all joined into the hub up in Dublin. So iNet, there's a nice interactive kind of flash slide there showing you the evolution of the networking in Ireland, and shows so you can actually have a look at that. You can put in the podcast notes.
If you send us, and it'll send out a tweet a link to that. So let's just back up again to maybe some higher level stuff. So we've established that the internet is a series of interconnected networks that all kind of follow a set of rules so that they can talk to each other. And it doesn't matter whether you're in Waterford or Dublin or in Tokyo or Sydney or somewhere in Nigeria or America. It doesn't matter where you are, that because we all follow the same rules, we can all talk to each other. Okay? But there was something I said again from that Technopedia article at the start, and I'm going to fire this at you, Amanda, which was said that often people use the term internet and World Wide Web interchangeably, but they're not actually the same thing.
No.
So could you make the distinction between the two?
So the World Wide Web came along then from a guy called Tim Berners-Lee. And what he came up with was the whole idea of the web page, really, I suppose, and HTML, which is the code that we use to write web pages, or certainly did use. And that kind of brought it all to the mainstream to us, because then we started to have the first web browser.
So up to this point, the internet was largely something that was used by academics, certain business people, defence groups, but it wasn't for Joe and Josephine Subs.
No.
Okay.
And I suppose when that started, then that's when we came up with the World Wide Web. We came up with our first browsers. So it was an application, I suppose, really that we could use on this internet. And that's where it kind of came into us, into the mainstream, and that's where it's took off. And I suppose just to mention there, when Richard was on about email made the internet very popular. You know, that we could actually send messages to one another like that. It was another, I suppose, application that we have that we can use on the internet.
It's still knocking around.
Yeah, so email and browsing, they were the killer apps. And I think that's one thing that has slowed down the adoption of IP version 6 is that your email and your browsing still works on IP version 4. There's no killer app that will only work on IP version 6 that would drive the adoption of a new addressing scheme as well. Like they're all technical details as to why you would adopt IP version 6, but like email and browsing and streaming are probably the main things that people are using on the internet as an ordinary consumer. And once they keep working, people really don't mind.
Yeah. I'm going to fire one last question at you. What's the difference between Wi-Fi and wired? Is there a difference?
Just the transmission, really, how the information is sent.
Yeah, I say it is in that our Wi-Fi, I suppose, speeds. The speed, probably the biggest difference is speed. Wired, we've always probably thought of wired as being copper wire, but more recently it's now fibre. So when you're talking about fibre to the home, you're just going to get a faster speed. The bits, the packets will, it's like going on the motorway to Dublin and going on the back roads. But yeah, well, one of the things that I often would tell students as well is that when the Wi-Fi is not working, Wi-Fi and the internet aren't the same thing.
Yeah.
So Wi-Fi is just a way of machines talking to each other, sending packets. So you can have Wi-Fi in your house, but the telephone line might be disconnected. So Wi-Fi is still working, but Wi-Fi is not connected to the internet. Yeah.
I often have that at home because I live in the country and our broadband is ufosok. It's terrible. And again, my wife would often say, the Wi-Fi is acting up again. And the Wi-Fi is absolutely bang on. It's the problem is getting from our local network out to the greater interconnected network is the issue. And I don't think we can solve that problem here in this podcast today. Unless, Richard, you have an ace up your sleeve.
Today's the day for the announcement.
Okay, so I think we've kind of covered it in fair amount of detail. We've introduced an awful lot of protocols, rules, terms there. But basically, if I was to summarize it all, what is the internet and how does the internet work? Well, it's a series of rules that people agree on and machines agree on that they all use to talk to each other. And then that allows us to put things on the internet, such as web traffic, watch Netflix videos, download a podcast and listen to it. And that's what allows all of those things to happen, is that's it. And it doesn't matter whether you're listening to a podcast, watching a video, sending an email, they're all going along the same infrastructure and they use similar rules. Is that fair enough?
That's it.
Yep. And
so again, I like cooking analogies on this, right?
Yeah.
So if we could use a cooking analogy that maybe you're cooking French cooking or doing some sort of like Asian street food, or you're doing meat and spuds in Ireland, okay, they look different, but they're actually very, very similar, and there's similar processes that are going on behind the scenes. But maybe if you're in a restaurant, you don't see those and you're not aware of them. You just care about what the meal that's served up on your plate is. Would that be fair enough?
Yep. We're still all using the same pots and pans, and you're still using a gas hob, or you're doing electric hob. Like, it's pretty much the same. You just have different flavors sitting on top of it. So it's
brilliant. That's it. Lovely. Okay, right. So I think we'll call it there for this episode of The Machine. We are available on Twitter at @machine_podcast. We're also on Facebook, Machine Podcast. Don't have Instagram or anything like that. Please leave us a 5-star review on iTunes or wherever you do listen to your podcasts. And hopefully we will talk to you again soon. Richard and Amanda, thank you so much for your time.
Thanks very much, Rob.
I might get that link off you so I can send out an old tweet with it as well. And if there's any other relevant parts from this show, we'll also send out some social media nonsense as well. Lads, thanks.
Thanks very much.